Hello, today I'm going over vertical ocean migration lecture. So we're talking about lecture that goes up and down the water column. So from the surface down to the seafloor. Usually when we talk about migrations, we're talking about migrations from an area on the surface to another area on the surface. For instance, gray whales migrate from Alaska to Mexico and then back from Mexico to Alaska. That's on the surface. You could think of that as like horizontal migration, or birds that migrate from Canada down to Mexico, things like that. This is the opposite. So we've got an image here of some land and then the ocean off the coast of this land. And then we see these bright plumes here of phytoplankton. The surface layers of the ocean are rich in food, making them highly attractive to marine life. That's what this stuff is. This is the basis of the food chain in the ocean. This is the algae, the phytoplankton that we find that is doing the same thing that plants are doing on the land. However, these layers can also be very dangerous due to the presence of many predators. You can imagine that the predators are going to hang out where the feeding grounds are. To balance feeding and safety, some zooplankton only spend part of their time near the surface. Zooplankton, by the way, they're like phytoplankton. They're very, very small, but they are animals rather than being plant-like. So just imagine a tiny, tiny microscopic insect, right? That's going to be eating things. So the zooplankton get eaten by a lot of other things. They want to avoid these dangerous areas. They engage in a behavior known as vertical migration. During the day, zooplankton stay in deeper waters, often at least 200 meters down. So daytime, you've got your photosynthesis from the phytoplankton happening up here. These zooplankton are going to stay down where it's dark. And 200 meters is pretty deep. It can get a lot deeper, obviously. There's other things that migrate deeper into the water, but these zooplankton hang out right around this area, avoiding predators. At such depths, there is little light, making it hard for visual predators to spot them. At nighttime, right here, zooplankton swim upwards to the surface to feed on phytoplankton and other organisms. So they go up there when there's less light and they try and feed off of that same stuff that was there during the day. Okay, here's an image of some zooplankton. They look like little bugs. They're tiny, tiny, tiny. Experiments have shown that zooplankton only perform this migration when predators are present. So that's an interesting thing. They'll know whether, well, it's not so much that they know an area has predators, it's just that in areas where there's predators, you'll see this migration, but in areas where there isn't, or where there aren't predators, they won't make that migration. They'll just stay up at the surface. It's not knowing one over the other, it's just whether it's safe or whether it's not safe. If predators are removed, the zooplankton stop migrating. This daily migration uses a lot of energy, especially for tiny organisms. If they can avoid using that energy, they're going to. They want to save the energy. It's better to do that. For a 2 millimeter zooplankton, a 200 meter swim is like a human swimming 200 kilometers. So these little zooplankton, when they move through the water, it's actually more like, it's almost more like syrup to them. It's not, because they're so small at that point, it's harder for them to move through the water because water molecules are attracted to each other. And so they actually have a difficult time moving through that. It takes up a lot of energy. Despite the high energy cost, the migration helps them avoid being eaten. This would be an example of like a larval fish, very small larval fish that is going to eat zooplankton. So anything teeny tiny is going to try and eat those things. And then these get eaten by larger things, so on and so forth. Some zooplankton also use the deep water to slow their metabolism and conserve energy. This resting period is compared to sleep or hibernation. So it also gives them a period of the day where they can be inactive. Now, this is another diagram kind of showing that same thing, right? During the day, there's certain things that are up near the surface, certain things that are down deep. And then at nighttime, a lot of that stuff from the deep will come back up to the surface. Many species of nekton, including fish and large shrimp, also perform vertical migration. These animals usually migrate to much greater depths than zooplankton. So that's a good example. You have things like squid and some fish that will go several times deeper than zooplankton do. It's easier for them to swim down to those depths too, remember. Like zooplankton, they rise towards the surface at night to feed. So same reasons. And then we've got a food web here. Remember, arrows point towards what is eating this thing. So we have our phytoplankton being eaten by krill, and krill are eaten by mackerel. Mackerel are eaten by cod, right? During the day, they return to deeper, darker waters where they are less likely to be seen by predators. This behavior helps them balance the need for food with the need for safety. Vertical migration in nekton is a widespread and important survival strategy in the ocean. So some of these top apex predators, these primary and secondary consumers need to avoid those apex predators. So they're going to be the ones that migrate vertically even deeper than the zooplankton. Okay, I hope this helps. Let me know if you have any questions. Thanks.